This presentation is part of the TI in Focus AP Calculus video series. In this video, I'll discuss the scoring guidelines for the 2019 AP Calculus exam, free response question AB4 BC4. My name is Steve Kokoska. I'm a professor at Bloomsburg University in Pennsylvania, and I'm a former AP Calculus chief reader. Here's an outline of the information presented in this video. I'll start by reviewing the free response question, and then the scoring guidelines used at the AP Calculus reading in Kansas City. I'll present a brief general summary for student performance on this question, and then I'll consider more detailed interpretations of the scoring guidelines and how these guidelines were applied in certain situations. I'll consider some common student errors where it's relevant, and where appropriate, I will present some specific scoring examples. This question involved a cylindrical barrel with diameter 2 feet collecting rainwater, and we're told that the water also drains out of the barrel at the bottom. The rate of change of the height h of the water in the barrel with respect to time is given, and we're reminded of the volume of a cylinder with radius r and height h. In Part A, we need to find the rate of change of the volume of water in the barrel with respect to time when the height of the water is 4 feet. In Part B, we need to determine whether the rate of change of height of the water with respect to time is increasing or decreasing when the height of the water is 3 feet. And in Part C, we're given an initial condition, and we need to solve a differential equation for h in terms of t. Part A was worth 2 points. The first point was for finding dv dt. Well, for understanding this is a related rates question, for taking the derivative of both sides of the expression for volume with respect to t. And the second point was for using the given expression for dh dt to produce an answer with the correct units. Part B was worth 3 points. The first point was essentially a power rule point for finding the derivative of minus 1/10 times the square root of h with respect to h. The second point was a chain rule point. That is, when finding d squared h over dt squared, we need to multiply by the derivative of h with respect to t. And finally, the third point was for the correct answer with a suitable explanation. Part C was worth 4 points. The first point was for separating the variables. Note that if there is no evidence of any separation of variables, the student earns 0 of 4 points. The second point was earned for 2 correct antiderivatives. The third point was for including a constant of integration in a correct manner and for using the initial condition. Note that if the student does not include a constant of integration, the most they can earn is the first 2 points. And finally, the fourth point was for producing the correct explicit expression for h of t. Here are some general comments about student performance on this question. In Part A, many students recognized that this was a related rates problem. However, some couldn't find the derivative of the expression for volume with respect to t. Here are some of the most common errors in Part A. Some students used a radius of 2 instead of 1, and 2 common incorrect derivatives of v with respect to t are given here. And some students actually made this problem harder than it was by involving proportions. In Part B, unfortunately, many students simply evaluated the expression for dh dt with h equal to 3. And some students only differentiated dh dt with respect to h. In Part C, many students were indeed able to separate the variables and correctly integrate both sides. And most students included a constant of integration at the correct point in the solution process. However, Here are two common errors in solving this problem. The first is sort of a universal logarithmic anti-differentiation, which doesn't work. And the second is often called the freshman's dream for squaring a binomial. Now, let's look more carefully at the scoring guidelines. The first point in Part A was for finding the derivative of v with respect to t. And to earn this point, we really need to see evidence of the chain rule, that is, the derivative of h with respect to t. Each response here earns the first point. In these responses, the student is using the product rule and has not yet used the fact that the change in r with respect to t is 0, but that's okay. Each still earns the point. Here the student has substituted r equal 1, and that's okay. In this next response, the student has left the constant r squared. And in the last response, the student has made an error in the radius, r equal 2 instead of 1. But they have still sufficiently conveyed the chain rule concept. In this first response, the student has used the expression for dh dt. And this second response is pretty minimal, but still conveys the concept and earns the point. If the student writes these two expressions, they earn the point. But this second response alone does not, because we don't know where the 4 comes from. It could be from the derivative of r squared. In Part A, these two expressions do not earn the first point. In this response, there is no evidence of the derivative of r with respect to t. And here, we believe the student took the derivative of r and h simultaneously. The second point in Part A was for the answer with units. And this must be our answer only, and the units must be correct, of course. Here are two common answers. If the student used this approximation for pi, they still earned the point. A bald answer, that is, an answer without any supporting work, earned 0, 0 in Part A. But if there was some reasonable work subject to professional judgment, the student could earn 0, 1 in Part A. Here are a few more examples of responses in Part A and how each was scored. In the first example, the student has conveyed the derivative of v with respect to t. However, the final answer is ambiguous. Because there are no parentheses, we have to read this as pi minus 1/5. So this response earns 1, 0. In example 2, the derivative is wrong, but it's still possible to earn the answer point with some reasonable work. But there is none, and the answer is wrong anyway. So this earns 0, 0. In example 3, the student uses r equal 1, finds dv dt, and uses the expression for dh dt. The student leaves the final numerical answer unsimplified, which is okay. And the units are correct. This earns 1, 1. In example 4, the student has conveyed the derivative of v with respect to t, but has labeled the final answer incorrectly. Remember, notation and communication of results are important. So this earns 1, 0. And in example 5, the student has not written enough to convey the derivative of v with respect to t. However, they do have the correct answer with minimal supporting work. So this response earns 0, 1. Part B was worth 3 points. Now, we expect the student to start this problem by finding d squared h over dt squared. So in this process, the first point is for evidence of correct use of the power rule. Here are 3 expressions that all earn the first point. The second point is for evidence of the chain rule. Now, most students earn the first 2 points with one expression. And here are 3 responses that all earn the first 2 points. In this example, the student does not earn the first point. There is a missing negative sign. But they have provided sufficient evidence of the chain rule. So this earns 0, 1. Similarly, in this example, the 10 in the denominator of the first quotient is incorrect. But they have provided sufficient evidence of the chain rule. So this also earns 0, 1. The third point in Part B was for the answer with sufficient explanation. And there was an eligibility criteria here. The student must have earned the second point, that's the chain rule point, and the second derivative of h with respect to t must appear. Now, the student's answer must say increasing, or it must be consistent with their incorrect derivative. And again, the word explanation here means supporting work. Here are 3 examples of supporting work. The student could also state that the second derivative is positive, or they could say that the derivative of dh dt is positive. Here are some example responses in Part B and how each was scored. Now, example 1 is pretty minimal, but all 3 parts are there. We assume that the student can see from their expression that d squared h over dt squared is positive. In example 2, the student does not earn the power rule point. They earn the chain rule point, and their answer is consistent. So this earns 0, 1, 1. In example 3, the student earns the first 2 points, but there just isn't enough evidence here to support the answer of increasing. So this earns 1, 1, 0. In example 4, the student has provided that extra work to convince us that they know d squared h over dt squared is positive. So this earns 1, 1, 1. And in example 5, the student does not earn the power rule point, but they do earn the chain rule point. They are eligible for the answer point, and their answer is consistent. So this earns 0, 1, 1. Part C was worth 4 points, a pretty typical distribution of points in a differential equation problem. The first point was for evidence of separation of variables. And here are some examples and how each was scored. In example 1, the student has started this problem by separating the variables, placing the constant minus 10 with the variable h, and included the integral signs. All of this is okay. This earns the first point. In example 2, also a valid separation of variables. This earns the first point. In example 3, we interpret this as a correct separation of variables. This also earns the first point. In example 4, even though there are no differentials, because the integral symbols are here, this earns the first point. In example 5, the student has not earned the first point yet. They could still earn the point with more work. And in example 6, if this is all the work on the page, or if the student continues work using this step, they earn 0 of 4 points. There is no separation of variables. The second point in Part B was for the correct antiderivatives, and there was an eligibility criteria here. The separation of variables must be in this form, where the constant k is one of these 6 values. Here are some examples and how each was scored for the first 2 points. In example 1, there is a valid separation of variables. There are no integral signs, but valid antiderivatives. So this earns the first 2 points. Note that there is no plus c here, but we'll deal with that in the third point. In example 2, there is a missing 10, but the separation of variables is of an eligible form. The antiderivatives are correct for their separation, so this earns 0, 1. And example 3 is pretty minimal. but earns both of the first 2 points. The third point in Part C was for the constant of integration and using the initial condition. And there was also an eligibility criteria here. At least one of the antiderivatives must be correct. The variable h cannot be part of a logarithmic function nor a linear function. The use of the constant of integration must be timely. That is, it must be introduced at the correct point in the solution process. And the initial condition must be used before any bad algebra. Here are some example responses and how each is scored. In this example, there is an implied separation of variables, 2 correct antiderivatives, a constant of integration, and an implied use of the initial condition. This earns the first 3 points, and could earn the fourth. In this example, there is an implied separation of variables, 2 correct antiderivatives, a timely constant of integration, but bad algebra before using the initial condition. This earns the first 2 points, but not the third, nor the fourth. In this example, the student earns the separation of variables point, but made an error in one of the antiderivatives. The constant is timely, and they use the initial condition. This earns 1, 0, 1, and they cannot earn the fourth point. And finally, in this example, the student earns the separation of variables point, but their antiderivative on the left involves a logarithmic function. They do not earn the second point, and they cannot earn the third or the fourth point. So this response earns 1, 0, 0, 0. And finally, the last point in Part C was for presenting a correct expression for h in terms of t. And this expression must be our answer only. Here are some expressions that earned the fourth point. Note that this expression does not earn the fourth point because the student has not presented an explicit expression for h in terms of t. So now we can put all of Part C together. Here are some responses in Part C and how each was scored. In this example, implied separation of variables and integration, timely use of the constant of integration and the initial condition, and an explicit correct expression for h. This earns all 4 points in Part C. Here, implied separation and integration, timely use of plus c, but bad algebra prior to using the initial condition. This earns the first 2 points only. In this example, implied separation, integration, timely use of plus c and the initial condition, but bad algebra to arrive at an incorrect expression for h. This earns the first 3 points. And finally, bad but eligible separation. One antiderivative is wrong, but we will continue to read for point 3. There is a timely use of the plus c and the initial condition. The student is not eligible for the fourth point. This earns 0, 0, 1, 0. At the AP Calculus reading, an actual briefing for the scoring of a free response question usually takes approximately 75 minutes. There is also time allotted in the reading rooms for discussion before the actual scoring begins. However, I hope this summary video gives you a good idea of how this question was scored. And just a reminder, there are lots of valuable resources on the TI website. There is material there involving technology and calculus, classroom activities, and lots of calculator tips and tricks for test success.